How are you? I hope all of you are all right at your places with your family. I will teach you digital communication in this semester, and this digital system is just the advance of analog system. We have studied in third semester about analog communication, in which we have studied amplitude modulation, frequency modulation, phase modulation, and so on. In this subject, we will study about digital communication instead of analog communication. In digital communication, we have different type of modulations like amplitude shift key, frequency shift key, phase shift key, pulse code modulation, and so on. This is this system is used nowadays for communication for error-free environment. Today we will start the first chapter, the introduction of digital communication system. This chapter basically have two topics: basic block diagram of digital and communication data communication system, and second topic is comparison of digital and data communication system with analog communication system. Today we will start with the basic block diagram of digital and data communication system. As we have studied about analog communication system in our previous class, which has information source, modulator, transmitter antenna, channel, receiver antenna, demodulator, and destination. Like same, digital communication system also have likely same blocks as analog communication system. This digital communication system has mainly three blocks: transmitter, channel, and receiver. Transmitter also have five blocks: information source, source encoder, channel encoder, modulator, transmitter, and receiver also have five blocks: destination, source decoder, channel decoder, demodulator, and receiver antenna. Now start with the first block in the transmitter, which is the information source. Information source is the first block of digital communication system which generates the information which has to be transmitted through the system. Suppose the information is simple, the word A. This is in the form of analog signal. Now, this information is converted into digital signal as studied in digital circuit. Digital signal means in the form of 0 and 1. Now, A is converted into 0 and 1 by source encoder, the second block of digital communication system. The source encoder convert the information into digital signal, that is in the form of 0 and 1. Here is shown the A is converted into 0 1 0 1 1 0. This is not the exact value of the A. Channel encoder is the third block of our digital communication system, which receives the signal from source encoder. source encoder, which has the signal in the form of 0 and 1, is transmitted to channel encoder, which add some bit into the digital signal as in the form of source address or destination address. Suppose here we add 2 bit as destination address as 1 and 1 at the end of the signal. Now the signal becomes 0 1 0 1 1 0 1 1. These two red color bits are added by channel encoder for destination address. This information along with destination and address and information generated by the information source is given to modulator. Modulator modulate this digital signal by some digital modulation. Here we use amplitude shift key, which has information as digital signal, carrier signal in the form of analog signal, that is in the form of sine wave signal, which has very high frequency. Now modulator modulate this digital signal as on and off. If signal is 0, then modulator gives output as 0. If signal is 1, then modulator gives a sine wave or multiple of sine waves in the form of instead of 1 as carrier signal. For 0 it gives 0, and for 1 it gives multiple or single sine wave of very high frequency, same as carrier signal. Modulator transfer its modulated signal to the transmitter antenna, which is responsible for transmitting our digital signal to the receiver through channel. Transmitter receives signal from modulator and give it to the channel for transmitting it to the receiver. Channel may be in the form of wire or wireless. Wire may be coaxial cable, optical fiber cable, twisted cable, and so on. This channel transmit the signal to the receiver. Receiver, first of all, channel give the transmitted signal to the receiver antenna, which receives the transmitted signal and transfer it to the demodulator. Demodulator is the reverse process of modulator. Demodulator demodulate the signal, that is, it again convert it into the original transmitted signal in the form of digital with destination address as 0 1 0 1 1 0 1 1. Last two 1 in the form of in as a color of red gives the destination address. This signal is transferred to the channel decoder. Channel decoder eliminate the address of destination by getting the information of destination address. After getting the destination address, channel decoder delete the address of destination. After deleting the address of destination, channel decoder give the information to the source decoder. Source decoder is again the reverse process of source encoder. This decoder decodes the information in the form of analog signal. That is, source decoder convert the signal from digital to analog. Means it is a digital to analog converter. After converting the digital signal into analog signal, source decoder gives the message to the destination, and destination get the information which is originally transmitted by information source, that is simple A. This is the block diagram of digital communication system, which has broadly 11 blocks. Information source generated information in the form of analog signal. Source encoder which convert analog signal into digital signal, means analog to digital converter. Channel encoder which add the address bit into the information. Modulator which is the digital modulator which convert this digital signal into modulated signal by some digital modulation. And transmitter antenna which transmit the modulated signal by channel to the receiver. Channel is the medium through which we transmit our signal to the receiver. Receiver antenna receives the transmitted signal and give it to the demodulator, which is the reverse process of modulator, means it will convert the modulated signal into the digital signal. Channel decoder, which is again the reverse process of channel encoder, means it will eliminate the destination address from the demodulated signal. Source decoder which convert the digital signal into analog signal, that is it is digital to analog converter, and the reverse process of source encoder. And last one is destination, which is which receives the transmitted information as destination point. This is the digital communication system. This block diagram represents the digital communication system in a very simple way, and this may be known as data communication system. It has we show this data communication system having 5 blocks: source, transmitter, transmission system, receiver, and destination. Source is which generates the information. Transmitter which transmit the signal by modulating it. Transmission system is same as channel. Receiver receives the modulated signal and convert it into the digital bit stream after demodulation and give it to the destination. Let us see one example of digital communication system which is used normally in each offices. This is the example of digital communication system. The workstation from where we want to transmit our signal to our friend as an email. Suppose we generate the signal, means we type our message as mail and give it to the modem. Modem is simply convert this message into digital signal and then modulate it and transmit to the network or channel. Here channel is public telephone network, means we gave our information to the telephone network to transmit our signal to our friend. Our friend have another modem which receives the information from the channel, which is telephone network, and then this modem give demodulate the signal, means signal received by modem is in the form of 0 and 1. Modem convert it into analog signal and give it to our system, our friend system, in the form of a mail. This is our example